Hey everyone, and welcome to lesson 3.5, Stretches of Trigonometric Functions. So to start off today's lesson, we're going to take a look at the graph of sine x. And we'll notice that the period of sine x goes from 0 to 2 pi. So the period of sine is 2 pi radians long. Now, in between the start of the cycle and the end of the cycle, we see some critical points. Now these critical points are where the function either reaches a maximum, the midline, or a minimum. Notice that these critical points that divide our function into 4 sections. So this section, 2, 3, and this 4th section here. To find out where these critical points happen, you will take the period, which in this case happens to be 2 pi, and you'll divide it by 4. So if you have the template printed off, you'll have all of this information with you. The important part is that you want to highlight this, saying that you take the period of your function. If you divide it into 4 sections, you'll get the distance for every critical point. So every pi by 2 radians in the graph of sine, you'll see that there is some sort of critical point. At pi by 2, we reach a maximum. Another pi by 2, we're back at the midline. Pi by 2 radians more, we hit the minimum. And then pi by 2 radians further, we end up at the end of the cycle. Now, in general, any sine function is in this form here. And in a few slides, I'll show you what all of these variables stand for. It's actually very similar to the polynomial functions we worked with in the first unit. So A is similar to the vertical stretch. K is similar to your horizontal compressions and stretches. D is your horizontal translations. And C is your vertical translations. But they do have slightly different terminology, different names. So we'll name those in a few slides. Notice that with cos, the period is still 2 pi, and if you divided it into 4 sections, every pi by 2 you end up with a critical point. So at pi by 2 we hit the midline, another pi by 2 we hit the minimum, pi by 2 radians more we hit a midline again, and then pi by 2 radians more back at the maximum. Okay, so the information here is on your template, and it's basically the exact same information as the sine graph. So we'll move on to the slide here that kind of explains what all of these variables mean. Taking a look at this slide here, we see that all of the variables that I mentioned earlier are highlighted. Now again, the A value is your vertical stretch, your K value is your horizontal stretch or compression, your D and C are your horizontal and vertical translation. Now if you take a look here, to find the period of a function, what you would do is take the original period of the function. So for sine and cos, we would take 2 pi and divide by k. So the period of the new function would be horizontally stretched or compressed depending on what the k value is. The amplitude is actually given by this very first number here. So the amplitude is A. Your horizontal translation, so moving left and right, is not called a horizontal translation. It's actually called your phase shift. And your vertical translation is your C. And actually C is the midline of your function. And remember to calculate your critical points. Those happen where you take your period and you divide it by 4. So to put this into action, what we'll do is take a look and read these rules over. But what we're going to do is start with the midline and mark our starting point, and then we'll use the critical points to help us graph the rest of the function. So if we are starting with y equals 4 sine of 3x, well, the amplitude is just the very first number here, so I know that the amplitude is going to be 4 units high. The period, well, that comes from taking 2 pi, because sine's original period is 2 pi, and I'm going to divide it by the k factor, which is right in front of the x there. So 2 pi over k is actually 2 pi over 3. Now, once I have the period, the next thing I like to do is calculate the critical points. So I'm just going to jump down here. Critical points happen every period over 4 radians. So if I take the period of my function, which is 2 pi by 3, and I divide by 4, well, remember that we can't divide fractions, so it's 2 pi by 3 times its reciprocal. Now if we were to work this out and actually reduce before we multiply, the 2 and the 4's will actually reduce. So multiply tops, we get pi, and multiply bottoms, we get 6. So just for now, I'm going to actually use this as my horizontal scale. So let's say every 2 lines would be a pi by 6. So there's pi by 6, maybe another one here, 2 pi by 6, and this is the only time I'll tell you not to reduce a fraction. It kind of is easier just to count by pi's. So this one would be 3 pi by 6, 4 pi by 6, and so on and so forth. Even in the other direction, we have negative pi by 6. Alright, so now that we have our horizontal axis on the grid, the next we'll do is the vertical scale. So notice that our amplitude is 4. So maybe we'll go up by 1s. Okay, and then once you have that plotted, now we can go ahead and make our function. So the very first thing I would do is plot the midline. Now notice that our midline is our C value, and in this case here, our C value really is 0. So our midline is actually going to be the x-axis. Okay, so when I plot my midline, I usually do with a dotted line. Okay, now we'll notice that there are no horizontal translations, so sine didn't move left or right, so I know that sine must start at 0. And I know that at the next critical point it reaches its maximum. So the maximum was 1, but we've multiplied it by that a value there. So the maximum now is actually 4. So at our critical point of pi by 6, I'm going to reach the maximum of 4. The next critical point is 2 pi by 6. Sine will reach the midline at the next critical point. The next critical point from here, we go down to the minimum. The critical point from here, back to the midline. Okay, and if we continue this pattern, the next critical point will reach the maximum, then midline, then minimum, and if I had a little bit more room, I would reach the midline again. So you can see that we've got 2 full cycles here, and if you connect the dots with a nice smooth curve, try not to make any curves pointy. Okay, we've actually got 2 full cycles of our sine graph here. We can talk about domain and range. You don't actually have to draw the graph before you state your domain and range. For domain, our function does go forever to the right and forever to the left, so we can easily state the domain and say that x is an element of all the real numbers. But for the range, we could talk about maxes and mins. So if we took our midline and added the amplitude, so our C value plus our A value, that would give us our maximum. Same idea with finding the minimum. If I started at the midline and I subtracted my amplitude, so C minus A, that would give us our minimum. So let's just kind of highlight that. That's a good little piece of information to know, because that allows us to tell our range or without even plotting our function. So our C value is 0, our midline is the x-axis, and then we went up by our A value, so 4. Our maximum is 4. Our C value, our midline, is 0, and if we subtract 4, our minimum would be negative 4. So that tells me that our range would be between negative 4 and positive 4. And you can clearly verify that on the graph that we drew. So with that in mind, let's move on to the next function. Okay, in this function here, we have y equals negative cos, and then we can actually write this as x over 2. So when we're taking a look at the amplitude, we're looking at the first number, and notice that we do have a negative 1 here. But amplitude really is a distance, so we always use the positive value. So amplitude here is 1. The period is, well, 2 pi over our k value, and notice that our k value is a half. So we can't divide fractions, so 2 pi gets multiplied by its reciprocal there, 2 over 1, and then we end up with 4 pi. Now if we take a look at our critical points happen every, well, let's take our period, 4 pi, and divide by 4. So the critical points happen every pi radians. Now we can actually do domain and range before we physically graph the function. We'll start with domain. Domain is nice and easy. As I mentioned in the last slide, unless otherwise stated, the domain for cos and sine will be any real number. Now for our range, we want to find the maximum and the minimum. So our max value is calculated by taking our midline and adding the amplitude, and our minimum is found by taking the midline and subtracting the altitude, as I mentioned earlier. So here we don't have any c value, it's just 0, and our amplitude is 1, and 0 minus 1. So we know that the range is going to go from -1 to +1. Okay, so now that we have our information out here, I'm going to come up with a horizontal scale. I'll take a look at the critical points. So every pi radian is where I will put a little tick mark. And because, as we mentioned earlier, our range is only between -1 and 1, we don't have to go too high up on the y-axis. And then once all that is set up, we can start plotting our points. Now keep in mind that we actually did have a negative value at the front. That tells us that our cos graph is reflected in the x-axis. So basically, we can graph this right away. We don't have to draw the original cos graph and then flip it. What we can do is realize that cos usually starts at a maximum. Because it's reflected, we'll start at the minimum. So we'll start at -1, and then at our next critical point, we hit the midline, and then the next critical point, we hit our maximum, and so on, and so on. And you just kind of continue the pattern there. Even in the other direction. And try to connect with a nice smooth curve. And there we have our graph of y equals negative cos of x over 2. Okay, so for example 2, I actually think this would be a really good class discussion. So if you would like, take a try and see if you can work this one out on your own. If not, this will definitely be something that we'll be talking about in class tomorrow. So I would like to actually move on to some word problems. So what we want to do is state a sine function that has amplitude of 7 and a period of 3 pi by 2. So remember that in general, the function of a sine graph would look something like this. So basically our job is to find values for A, K, D, and C. So the amplitude in our question is given to us, very straightforward, so we know that A must be equal to 7. Now in this case here, we're given the period. We know that the period is 3 pi by 2. And we know that we actually calculate period by taking the period of sine, which is 2 pi, and dividing it by k. So if we just focus on this little tiny equation here, we can actually rearrange and solve for k. So what I'm going to do is I take a look at the denominator and I see that there's a 2 and a k. So to get rid of the fraction, I multiply both sides by 2k. Now on the left side, if I multiply, the 2's cross out, and what I'm left with is 3 pi times k. And on the right side, if I multiply by 2k, the k's will cancel out, and I'm left with 2 times 2, which is 4, and then pi. If I actually divide both sides by 3 pi, I'm left with 4 pi over 3 pi, and the pi's cross out, so just 4 over 3. Now notice that we're not given any information about a horizontal translation or a vertical translation, so both D and C will be 0. So a function that has these properties would be 7 sine, and then our k value is 4 over 3x. Alright, now given a graph, we can actually come up with the equation. Again, all we need are the values for A, K, D, and C. Now A is quite easy to tell. We know that the midline actually in this graph happens to be the x-axis. So the distance from the midline to a maximum is 5. The midline, we've already stated that the midline was the x-axis, so our vertical translation is 0. To find the k value, first we should state the period. So the period of this function, let's say we go from peak to peak. The period of this function, you can clearly see on the graph, is pi. So period equals pi. Know that the period is also calculated by doing 2 pi over k. So just focusing on this, and a little quick cross multiplication, pi times k is equal to 2 pi. Divide both sides by pi. Our k value is 2. Now taking a look here, this function actually has a maximum that's right on the y-axis here. And functions that have a maximum on the y-axis are very similar to a cos graph. So we can say that d equals 0. There'll be no horizontal translation if we use cos. So a possible equation here would be y equals our a value, amplitude, cos, our k value is 2, and then our angle is x. And there is no c value, so plus 0. Now, if we decided to call this a sine graph, that would be the starting point of our sine graph. We'd have to consider a horizontal translation. I mean, it is possible, but maybe something that you might like to avoid. So whenever I do these questions, I always try my best to get a horizontal shift of 0, provided we use the appropriate trig function. Okay, in example 4, I have given you here the graph of 3 sine of 2x. And basically we want to state the coordinates of all the points here. Given this equation here, because we know that there is no vertical translation, so our midline is the x-axis, and that our amplitude is 3, we can easily see that we have a maximum at 3 and a minimum at -3. So our vertical scale actually goes up by 1s. Okay, and now let's try and figure out something for our horizontal scale. The horizontal scale will come from the period and the k value. So remember that the period is calculated by 2 pi over the k value. The period of this function is actually pi. So now what we can do is take our period here and divide by 4, so we know that the critical points are going to happen every pi by 4 radians. So we can see that right here we have pi by 4. The next critical point would be pi by 4 again, and each one of these tick marks that represents a critical point would be pi by 4 radians. So notice for point A, we go left on the x-axis, pi by 4 radians, and down on the y-axis, 3. For point B, notice that we go right on the x-axis, pi by 4, and then up 3. For point C, we've gone right on the x-axis pi by 4 twice. So 1 pi by 4, 2 pi by 4. And then we stayed on the x-axis, so our y value would be 0. The only thing is, for this one here, I would suggest reducing that x value there. So call this pi by 2 and 0. And then finally, for point D, we've gone 1, 2, 3, 4, 5 pi by 4s. And then up on the y-axis, 3 units. So those would be the 4 points. Okay, so that's it. So the important things are to figure out the y scale and your x scale coming from the amplitude and from your critical points. So that's it for today's lesson. And as always, if you ever have any questions, please make sure you ask in class. Have a great day, guys.